Okay. Before every blood transfusion, we must do direct and indirect methods, ABO blood group typing, as you have done it. But after blood group typing, but before blood transfusion, again, we must do another test that we call it cross-match. Maybe you have heard about that or you read about that in some text. We have two kinds of cross-match, major and minor. But they have some difference between them in the laboratory. But as a medical student, just enough for you to do about cross-match. Forget about major or minor. It is some methods in the laboratory for lab technicians. For you as a medical student, just concentrate on cross-match. How we can do the cross-match test after blood group test and why it is necessary doing the cross-match test. You know, as I explained for you, we have some antigens and antibody naturally in our body. On the surface of RBC, we have maybe antigen A, B, both of them, none of them. In our plasma, maybe we have some expected antibody in front of that, something like anti-A, anti-B, both of them, none of them. Anti-A, B, both of them, none of them. As you see now. But we have some unexpected antibody again in ABO and RH system. Something like this. Can you tell me unexpected antibody? Something like IgM, complete IgG, incomplete IgG. We have two kinds of IgG. They are unexpected antibodies that you cannot detect it by direct and indirect method, even by anti-D factor in RH. Because of that, in the laboratory, after every blood group typing and before every blood transfusion, we must do another test that we call it cross-match, and it is so important for you as a medical student, and God will in the future, when you will be a doctor, you must refer your patient to the laboratory for doing blood group test, RH test, and after that, cross-match test before every blood transfusion. For cross-match test, in the laboratory, we put 3 tubes. We have 3 tubes. In the first tube, we add 2 or 1 drop of recipient serum with 1 or 2 drops of donor red blood cell or vice versa. This is related to major cross-match. In minor cross-match, this is vice versa, but all of the steps similar to each other in major and minor. I told you, it relates to our laboratory. It doesn't relationship with your work in the clinic. So just consider 2 drops of recipient or donor and 2 drops of donor or recipient red blood cells. We mix them in all of these tubes. In the first tube, we put it in the room temperature. And after that, we will centrifuge it in 15 minutes and bring it. Maybe you see the agglutination after mixing them with each other, something like this that you do on the tile. We do it in the tube. If you see the agglutination, maybe you don't see the agglutination. What does it mean? In the first tube, because it is cold temperature, you don't warm it, you can detect unexpected all of the antibodies that something like IgM. Maybe you cannot detect on the direct and indirect methods because they are unexpected antibodies. They are not anti-A or anti-B. They are unexpected. Now you can detect it. If you have agglutination, it means that you have contamination between not anti-A or anti-B, between IgMs and anti-IgM. How about other tubes? In the second tube, again, I mix the recipient and donor RBCs and serum with each other. But in these tubes, I want to detect one unexpected antibody, something like IgG, that they relate to Rh factor mechanism. For detecting IgG, that we have two kinds of IgG, complete IgG or incomplete IgG. If you want to detect the complete IgG, they are stronger, and incomplete, they are weaker. When we mix the donor and the recipient serum and RBCs, after that we put it in the incubator 37 degrees centigrade for half hour, and after that again we centrifuge it. Again we read it. Maybe you have agglutination, maybe you don't have agglutination. If you don't have agglutination, it means that you don't have any contamination between complete IgGs of donor and recipient. So it doesn't have any problem. But if you see the agglutination, there is a contamination between the IgG of donor and recipient. How about the third one? Again, we mix, and after that, again, we incubate in 37 degrees centigrade, and after that, again, we read it. Maybe you have agglutination or not agglutination. If you have agglutination, it means that there is some contamination between incomplete IgGs of donor and recipient. Let's explain about complete and incomplete IgG and explain about these two tubes. We just warm them, and after that, for detecting these unexpected antibodies, because they are so weak in the plasma or on the RBCs, we need some extra materials. For the second tube, we add albumin. Because of that, we named this tube albumin. In the second one, we need antibody, that we call it anti-human globulin. When you add albumin, the albumin decreases the negative charge between the antigen and antibody. If you have complete IgG, they start to mix with each other, attach with each other, and make agglutination. And you can detect the IgG complete. Here, the incomplete IgGs, what does it mean? You know, every antibody has two arms. If the antibody attached to antigens with both arms, we call it complete. But some antibodies just attach to antigen just with one arm. And because another arm is free and it cannot attach to antigens with another arm, you cannot detect it. Just when you add another antibody, that it comes and attach to this antibody, and now this antibody can attach to antigen, and now you can detect the incomplete IgGs. In the third tube, we add this material for helping to detecting weak, unexpected, warm antibodies like IgG incomplete. Okay, now we do the cross-match test. At the end of the time, we have 3 tubes.